Today we'll discuss about JEE Men's 2016 paper Physics. Students, let us solve the next question. The question here is a point particle of mass n. Point particle is a particle in the form of a point. That means its mass is there, but its volume is nearly zero. Moves along the uniformly rough track. So this track P, Q, R, P to Q, Q to R. So this is the path along which the particle has to move, which is uniformly rough. That means the coefficient of friction is constant everywhere from here to here, are shown in figure. The coefficient of friction between the particle and the rough track equals mu. So from here to here, the coefficient of friction is mu. So this is friction mu. The particle is released from rest. So here u equals to 0. So from u equals to 0, it is released from the point P and it comes to rest at a point R. So it slides down like that. Then it slows down and stops here. The energies lost by the ball over the parts. The energies lost by the ball over the parts PQ and QR of the track are equal. That means what happens is, from here whatever energy with which it comes down to this point, there is a loss of energy. The whole of energy is now lost. So how it is lost? Half is lost here and half is lost here. That is equal loss. This is equal. So the energy the particle possesses at P is equally lost. That means half is lost from P to Q and the remaining half is lost from Q to R. And no energy is lost when the particle changes direction from PQ to QR, because PQ is this direction, the particle is going in that direction, suddenly it changes the direction to QR. So during change in direction, some energy is lost, but that is neglected. So it says no energy is lost. The values of the coefficient of friction mu, this you have to find, and the distance QR. So this distance, suppose this distance is x, that also you have to find. So this is the question and you have to solve it. Now to solve this, what we'll do, we'll first draw the diagram. We'll draw the diagram from here to here. This is P, this is Q, and this point is suppose R. Now the particle is released from here, so it comes down like this. It follows this path. So when it reaches here, it has certain velocity in that direction. Now what happens is, this height is given as 2 meter. So I will write this height as 2 meter. So this height is 2 meter. And this angle is 30 degree. This is a horizontal surface. This is a horizontal surface. Now the coefficient of friction is mu that you have to find. Now it is only the case of work. This is a problem based on work energy power. Here the energy it possesses, because of that energy, the whatever is energy here will be same as the energy here. That means the energy here is lost and it is zero here. What is the energy? Energy in the form of kinetic and potential. So equate the total energy here with the energy here. So the remaining energy is lost in between the work done. When it comes down, there is a loss of energy due to friction. So friction will lose half of the energy from here to here and half from here to here. So let me solve the question, then we'll discuss by any other method possible to solve this. First simple method, so what is the energy here? The energy at P, at this point, the energy is purely because it is released from that point, so its velocity is 0. So its kinetic energy is 0. What are the potential energy? Is because of the height mg h. M is the mass of the particle. Because of this height, this is the energy. So this potential energy here is converted to kinetic energy and by moving down the track. Now the thing is that half of this energy is lost. That means the total energy here is mgh. Half of this is lost during this particle moving from here to here. When the particles move from here to here, what is the work done? Work done. Allied work done from P to Q by friction. But before that, we also first let us solve this. Then we will discuss one more thing. Work done from P to Q by friction is the work done by friction is the force that is acting in the opposite direction, because when it slides down, the particle slides down, the friction is acting in the opposite direction. So the force of friction is acting in the opposite direction and the displacement is like that, so it is negative. Negative means the work is negative. Negative also energy is lost. So I am not writing that negative part, I am just writing that this the energy is lost. So F and that distance, that means this is P and this is Q, so the distance is PQ. So over this distance, this is the work done. And what is the force of friction? Force of friction is mu into N into PQ. And what is PQ? Because mu you have to find out. And what is this N? In this inclined plane, if you draw the free body diagram of this particle, this is mg vertical acting downward, and this is normal direction like that. So this N is this normal direction. But then because this is 30, so this angle will also be 30. Then this will be mg cos 30 and and this will be mg sin 30. So mu is, so while it's journeying, this particle is experiencing two vertical forces in this along perpendicular to the plane. One is n normal direction and the other one is mg cos theta. These two will balance each other because the body has no movement in this direction. So the body only moves in that direction. So therefore n becomes mg cos theta. So n is mg cos of 30 into this distance pq. So from here, that what is pq, that also we'll see here. You can see here this pq is unknown, not given, but I know this height h, which is 2 meter, and this angle theta. Suppose that this distance is, I will say z. Then this is z, then this is theta, this is z cos theta, and this is z sin theta. So h is z sin theta. That means z is h by sin theta. So h is 2 and sin theta is sin 30, which is half, so it becomes 4. So z is 4 meter. So I'll put it here directly. Z is 4 meter. So mu mg cos 30 and this is h by sin 30, that is 4 meter. Now m is not given, g is not given. Cos 30 I can write mu mg cos 30 is root 3 divided by 2 and this is 4. So this is 2 cancels. This is 2 root 3 mu mg. This is the work done by friction. The friction when the particle moves from P to Q. So this is the energy lost. That means this is the energy lost from P to Q. And we know that the total energy initially the particle is having is mgh. mgh is initial energy. So initially the particle P was having this much of energy mgh. Now according to the question, half of this energy is lost from here to here. That means half of mgh is equal to this energy lost. Energy lost from P to Q. If I do that, then what I have? Then I have, out of this total energy, half of this energy lost in the form of work done due to friction, which I've got as mu mg and 2 root 3. Then mg and mg will cancel out. Here mu equals to h divided by 4 root 3. But h is given in the question as 2. H is given in the question as 2. So therefore, I'll write 2 divided by 4 root 3, which is 1 by 2 root 3. 1 by 2 root 3. So this 1 by 2 root 3 is 0.29 approximately. If you want to solve this, then how do you do that? This is 1 by 2. 1 root 3 I will multiply here, and root 3 I multiply, it becomes 3. So this root 3 is 1.73 divided by, this is 6. If I, for the time being, write this as 18, 1.8, I round off this to 1.8 because this is 7, I write 1.8 divided by 6. Then this is 18 by 6 into 10. This is 3, this is 0.3. If it is 0.3, you can see here it is nearly equal to 0.3. So therefore, you can see that if it is 0.3, then this is also nearly 0.3. In the options you have 0.29. So either 3 or 4 will be the answer. Let us solve for the next. What is the distance from here to here? Okay. So we'll continue with this. So we will continue with this, that mu we got 0.29. Okay, now the next part is to find this distance QR that I have considered as x. So how to find this x? The mu coefficient is same everywhere from P to R. Now for that remaining part Q to R, see this distance is x. Now this distance is x, and the energy that is to be spent here as the particle enters, it enters with the energy mgh divided by 2. This particle enters with this energy with certain velocity. Whatever velocity is not important, but finally this energy has to be lost from here to here within the distance x, and that is lost because of the work done by friction. So work done by friction from here to here is given by work done by friction from Q to R equals to, again it is mu n, mu into n, that is the force of friction, into the distance is x. Mu n is in this case now is mg, because this is in the horizontal surface. When the body is in horizontal surface, the mg is vertically acting downward and normal direction is upward. So in this case the n becomes mg. Earlier it was mg cos theta, and this is x, and this energy must be equal to this energy because this energy is lost in the form of this energy. So this energy is converted to this energy. So therefore mgh divided by 2 must be equal to mu mgx. If I solve this mg cancels. Then from here this ax can be obtained by h by 2 into mu. So that means x equals to, h is 2 meter, 2 divided by 2 by mu. 2 cancels, is 1 by mu. So therefore x equals to 1 divided by 0.29, which is approximately equal to 3. So if I solve with 3 approximately, then this is 1 divided by 10 by 3, which is approximately 3.33. 3.3 approximately, because in exam approximate results are more important than this. So it is 3.3 means this is more near. Out of these two, this should be the answer, which is 3.5. That means if I go for 0.29, obviously I will get 3.5. But I don't have to go for that, because to solve this you will lose some time. So there is no need to waste your time. So therefore, you have to predict this way, because this is easier calculation and that will give you the right answer. So therefore, if you see the options to this question, the answer is the 0.29 is the coefficient of friction, and this distance is 3.5 meter. Now I was telling you that whether you can solve by any other means or not. Obviously you can solve. Throughout the journey from here to here, I can use one theorem that is known as work energy theorem. That theorem is called as work energy theorem. So if I use work energy theorem, what I should have got? In work energy theorem, I should have got like that. Okay, suppose I use work energy theorem, work and energy theorem. In work energy theorem, the change in kinetic energy, the particle moves down like that and moves like this. So from here, the kinetic energy is 0. Here also at the final point they also comes to rest, the kinetic energy is 0. So the initial kinetic energy is 0 and the final kinetic energy is also 0. That means the change in kinetic energy is net work done. Net work done means the total work done. I will write the final kinetic energy minus initial kinetic energy, 0 minus 0 is net work done. That means work done due to gravitational force plus work done due to friction and plus work done due to normal direction. Then total work done, and you equate it to 0. If I do that, just I will solve for one more step and not complete solutions, but see this 0 equals to work done by gravity. When the body moves from here to here, the gravitational force is independent of the path, it depends on the height. So it is this by this, the body is coming down, gravitational force is also in this direction, so that is again mgh by 2. Mgh is the lost in the work done is mgh. This is how you find the work done, because this is the vertical height that is important. So this vertical height h, so the work done by when the body comes from here to here or here, the work done by the gravitational force is mgh. From here to here, the work done by gravitational force is 0, because force is downward and the displacement is in the forward direction. So this angle is 90. So only this work is the work done by gravitational force. Now plus work done by friction. Work done by friction. Friction is a negative, so it is minus. And minus of what? Minus of, you can see here the force of friction is we already calculated, that is mu mg cos theta. This is the force of friction into this displacement, which already we have calculated at h by sin theta. This is minus because the displacement is in this direction and the force of friction is acting in the opposite direction. Similarly, from here to here, and there is no work done by normal direction, because normal direction is perpendicular to the displacement. Similarly, there is no work done by normal direction here, because normal direction is perpendicular to the surface. So there is no work done by gravitational force as well. So there is only work done due to the frictional force, which is also negative, and that is mu mg into the distance x. So whole of this thing is equal to 0. This is exactly what we have done. If I would have used it, then also I would have got the answer. But this is one equation and you have to use another equation, because this equation mg you can make it 0, h minus mu h cot theta minus mu x equals to 0. This is h. So from here, this is one equation. This equation cannot be solved only with help of that. We have used two equations. Here mu is unknown and this x is unknown. Now what we have to do is, the question that is in the question this is given that the half of the energy mgh by 2 is used in this first case, and half of it is used in this case. So out of that concept you have to use that mgh by 2 is equal divided by this work done and this work done. That means these two work done are same. That means these two work done are same. That I can use these two equations, equate these two equations as well. I can equate these two equations. If I equate these two equations, then mu h cot theta is mu into x. So from here I can get x also. X is h cot theta, that is I'll put the value h is 2, cot theta is how much? It is cot 30. Cot 30 is root 3. Okay, if I put that, that is 2 into this is 1.73, this is 6, 4, 3.46, or nearly it is 3.5, which is our answer. 3.5 also is the answer. So once you get this here, then you go back to put this in this expression and then get the value of mu. So in that case, we just use the idea. Okay, thank you.